Thanks very much, Sam, and thanks everyone for joining. It's an absolute pleasure to be here. So, as Sam said, I'm Richard Lowes. I work primarily at the Regulatory Assistance Project, and I'll be talking today about how cheaper electricity is needed to drive clean heating, in particular heat pumps, and about the steps and policies that governments can introduce to make electricity cheaper. In terms of today's discussion, I'm going to be talking about a report that came out in December last year. You can see the front cover of the report there, the same title as the webinar. Also, there's a QR code if you'd like to access the report and go into the details. I'm not going to have time to go into full details of everything in the report today. I'll just be touching on the surface of some bits. So I'll be talking about the role for clean heating and what those clean heat technologies might be and how pricing reform is needed to drive them. I'll be talking about energy prices, how they're constructed and how social elements of those prices are key to what consumers actually end up seeing. I'll be talking about action that some governments have already taken that can inspire other governments to make progress on this issue, thinking about how we do this fairly, efficiently, and in a way that suits everyone and works with the energy system. And then I'll be providing some policy principles at the end of the presentation. So just quickly, on the Regulatory Assistance Project, or RAP, as we tend to call ourselves, we're an independent, non-partisan NGO, and our work is focused on creating a clean, reliable, equitable, and cost-effective energy future for everyone. We were founded in '92 in the US by energy regulators who were looking to share best practice across US regions. And we're now a global organisation with offices and bases in the US, China, Europe, India, and further afield. And we deliver non-partisan technical advice to policymakers and regulators. We think about the energy system broadly, looking at interactions between grids, generation, and users. And we work regionally in certain areas and countries, globally, providing global leadership and expertise. And we also work in more specific regions and spaces when that is requested. And specifically, our work focuses on policy and regulation associated with energy systems. At RAP, I'm our global lead for heating and buildings, and it's been my great pleasure to work with partners to produce this work on price rebalancing. So, clean heating, what is it and what does it mean? Well, when I think about clean heating, I guess there are three things that I really think about. One is that the heating is low carbon, doesn't produce climate change causing emissions. Another is that the heating is low pollution, doesn't produce local emissions. That might be soot, particulates, or NOx emissions, for example, but it could also be waste products. And that therefore means that typically clean heating is likely to be low combustion, though not always. And also, clean heating probably has to be efficient, efficiently used. So ideally in a building which is energy efficient, but also efficient in a way that minimizes primary energy demand, reducing the need for extraction of resources and products from the ground and from the earth, be that fossil fuels or be that products used to manufacture appliances. And just to introduce the scale of this challenge, this graph on the right-hand side, which we included in our report, is from the International Energy Agency, and it shows the rate of emission reduction change needed to meet their net zero scenario by 2050. And if you see this, the stacks on the left-hand side are previous years of emissions going up to 2022. The stack on the right-hand side shows the effective target for 2030. And we're basically talking about halving emissions from heating over the rest of the decade to get to this net zero goal. And that means significant emission reductions from those different chunks of the bar, which are natural gas, oil, and coal, which are providing the majority of the world's heating demand at the moment. However, I should say we're not making progress as significantly as suggested is needed by that graph. So I've talked about clean heating more broadly. As a subset of that, heat pumps are a large part of that subset, and they're absolutely key to a clean energy future. And this bar graph on the left is from McKinsey, from their net zero report. And it basically shows total sales of appliances for heating by the decade. And what you can see starting on the left is sort of where we are with the biggest chunk being gas appliances and fossil fuel boilers. By the end of by 2050, heat pump sales dominate that appliance sales market to the point where really they are the dominant heating appliance in the world. And that growth is pretty rapid to get there, and it's a significant change from where we are today. And that's really a big part of how we get to a clean energy future. At the same time, heat pumps obviously rely on electricity to run. So I'll come back to the performance of heat pumps and how they do actually produce heat. But we have seen clean electricity technologies, which are obviously vital for cleaning up the electricity grid, fall rapidly in terms of price of generation, really with onshore wind and solar being cheaper than fossil fuel alternatives on a levelized cost basis. And in theory, and I'm very hopeful that actually we can get to a point where clean heating is also significantly cheaper than the fossil fuel heating it is replacing. And we might not be there at the moment, but continued technological innovation is taking us in that direction. So heat pumps are very efficient. They produce maybe 3 or 4 units of useful heat for each unit of electricity they consume. And as the image on the left shows, that is because much of the energy that is coming out of a heat pump and going into useful work into a building is being extracted from the environment. In the case of air source heat pumps, that's coming from the air. And in the case of ground source heat pumps, that heat's coming from the ground. But typically, you can put 1 unit of electricity into a heat pump and it will work its magic, although it's not really magic, it's just thermodynamics, and it will produce or spit out 3 or 4 units of heat. That therefore means that you've got a very, very efficient way of producing heat, which has a significantly low resource requirement in terms of primary energy demand. So heat pumps really are an excellent way of reducing primary energy demand. And for countries heavily reliant on imports and worried about energy security, they're a really, really good way of securing up energy supplies because they need so much less energy in the first place. But despite this efficiency, which is very significant, electricity is significantly more expensive than gas or other fossil fuels used for heating typically. And so while electricity can be more expensive because the heat pumps are so efficient, it can't be many, many times more expensive. And that ratio is really, really important. And I'll come back to that in a minute. But basically, we don't want to see any ratios of electricity to fossil fuel prices above 3, because that will erode the efficiency benefits of heat pumps. And it's worth saying at this point that for the prices of electricity that consumers and households and building owners see, taxes, levies, and regulation, all socially created parts of those bills, are often a key driver of electricity prices. So pricing is one very, very important part of delivering heat pumps at scale. And it's worth pointing out, I think, at this stage that it's just one part of the puzzle for the deployment of clean heat and heat pumps. And actually, mixes of policy measures are needed to drive the heat pump market and the clean heating market in at a speed and at a rate and at a way that is that matches net zero and climate change and energy security goals. And to form those packages, policymakers need to think about 3 main things. They need to think about these 3 pillars here on this diagram, which is from our heat pump policy toolkit. The first one is around the economics of clean heating and the use of market instruments to drive clean heating. And that really links to prices, the prices that consumers and building owners see. Policymakers also need to think about the availability of financial support for building owners. That might be things like subsidies, it could be finance. That's because heat pumps often, but not always, do cost more than the fossil fuel systems they're replacing. Some heat pumps can be significantly cheaper, notably air-to-air heat pumps, but not suited to all building types. And the final pillar is regulation. So governments also need to consider things like end dates, market drivers, and planning to make sure that the buildings market, homeowners, and the heating market knows what's coming and knows where to invest. Together, all of those things need to be coordinated, need to be communicated, but you need all of those things to drive clean heating at the rate that we need. However, absolutely fundamental to that is the topic of this webinar, which is pricing. So basically, you cannot expect a building owner to switch to a new heating source if it's going to cost more money. That will politically and socially be very, very challenging. And therefore, while all of these things are important and required, it's absolutely fundamental that you get pricing right. Because if the pricing's right, then it allows governments to potentially think about slightly more powerful policies associated with regulation. This is the first step on the way, and you certainly can't regulate without getting the prices right, because you do not want to be telling people that they're being effectively forced to go onto a new heating system, and their prices will go up. That's obviously a non-starter for politicians and policymakers. Now, I just want to point out here, and we can't show clear causation, but there is an obvious relationship between the relative cost of electricity and the penetration of electric or heat pump technologies for heating. Now, the graph on the left here is from the US, and that shows the proportion of households with electrified heating compared to the price ratio between electricity and fossil fuels being used for heating. What we see is that where the price ratio is supportive of electrification, where electricity is relatively cheaper, we do see a higher penetration of electric heating. And similarly in Europe, the trend line is a very similar shape. We see more heat pumps, and the one on the left is electrified heating, the one on the right is heat pumps because of data availability, where we see a relatively good electricity price, a relatively low electricity price, we do see a higher penetration of heat pumps. Now, obviously, we cannot prove exact causation there, and there are wider structural system issues at play, partly perhaps because the system is already highly electrified, and that's leading to lower costs. But we do see a causation between cheap electricity and the uptake of electrified heating. So a key takeaway from our report is around what this ratio should look like. And we had to settle on something. And basically what our recommendation really was to governments around the world looking at driving clean heating was that while the cheaper electricity is the better and the lower the ratio is the better, policymakers should typically be aiming for a maximum electricity to gas or fossil fuel heating price ratio of 2.5 to 1. That is, electricity should be no more than 2.5 times more expensive than the equivalent fossil fuel heating source in that particular country. This 2.5 ratio ensures that heat pumps with typical performance levels always see lower running costs than the fossil fuel equivalent. It also means that heat pumps which are slightly less efficient, so ones that may have been installed not very well or are just older, will always be cheaper to run. So this is a broadly safe level for policymakers to aim for to ensure that people can happily switch to heat pumps and see lower running costs. We added to this sort of takeaway that anything above 3 should be a real cause for concern for policymakers, as this will often erode efficiency benefits of heat pumps. It's possible that you can get away with above 3 if you've got well-designed systems and the market's designed around that heat pump, but actually anything above 3 should really be a cause for concern. So back to energy prices and the fundamentals of them. It may sound obvious or perhaps not, but energy prices are socially constructed to some degree. Governments use energy prices to deliver technology innovation policies. It might be to deploy a particular technology or to just grow a particular industry or market. Energy bills are also used to raise taxes. Conversely, sometimes taxes are used to drive behavior in the energy system, and that might be towards electrification, or it could even be towards fossil fuel use potentially. And those three things are in addition to the actual costs of the energy, the sort of true market value that the energy has for consumers, which includes distribution charges, the cost of moving it around, and also the costs to actually produce that energy. And it's also worth adding that often these innovations, taxes, and targeted sort of supports often sit on electricity rather than fossil fuels. And that's because electricity is used by everyone. Nearly all building owners have an electricity connection. A much lower proportion would have a gas connection or an oil connection, for example, or an oil use. So while these prices are socially constructed, and they're at the whim of policymakers and regulators, on the other hand, it does mean that policymakers have a significant amount of control over what the final prices and the ratios of the prices look towards energy users. These price ratios vary wildly, and I'll show you some examples of these, but governments do fundamentally have quite a lot of control on these issues. So this is a complicated picture of the price ratios in Europe. And you can see in blue, this is where countries have a ratio of less than 2.5. In yellow, it's between 2.5 and 3.5. So areas for concern where work might be needed. And in red, it's ratios above 3.5. And these areas where it's worth flagging there's a significant problem. It varies significantly by geography, by weather, and by energy system, of course. And some of those geographical factors are important, but actually the political factors are often much more important than those geographical factors or those energy endowment factors. And so the graphs on the right-hand side show the costs of electricity and gas in most European countries and what goes into them. And I'm not going to say much about the detail of them because they're in the report, but all of the elements really vary quite wildly. Network costs, which you might assume would be similar everywhere, vary wildly. The tax and levy elements of bills really does vary significantly, and those tax and levy elements are in red and green. And where there's a green below the bar, that's where a tax exemption or a tax discount or reduction has been applied. Because, of course, taxes can be used to bring bills down as well as to raise them up if those taxes are removed. But the point here really is that there is a huge amount of potential for governments to make efforts here on pricing if they really want to. And I'll give some examples of how that can be done, but firstly talk about some other regions. So the bar chart on the left here shows price ratios in selected Chinese provinces. Apologies for not having a map here. It just makes a lot more sense because of the varying size of these provinces and cities to have them on a bar chart. Everywhere in China is pretty much below 3 as a price ratio. So a few places are above, so two places in this example are above 2.5, but only just. And so really across China, the price ratio issue is not significant when it comes to electrification of heating. In many ways, it actually makes a lot of sense for building owners to electrify their heating if they're able to. Although local development planning means that might be beyond the ability of the household. It might be a city-based regime, for example. And then I think the graph from the US is fascinating in that, and this includes Canada as well. So this is North America and the prices of electricity compared to fossil fuels used for heating. In some states, that's oil because there's a higher prevalence of oil than gas. But you see these incredible variations, and partly it's down to policy in the US, but partly it's also down to and Canada, I should say. Partly it's also down to availability of resources. We see a ratio of 1.1 in parts of Canada, and that's primarily due to availability of renewable hydro resources. We also see some very low ratios in the southeast US. Interestingly, that seems to be down to very high utilization of the power grids because there's so much cooling demand in some of those states. And there's quite a complicated picture. There is this band, I guess, across the north of the US where prices are quite high. But it doesn't need to be that way necessarily. And when we see, in even colder regions, prices which are much, much lower. So on to what you can do and what has been done. So countries are already making progress to reduce these price ratios, partly to reduce the burden on households in general, but partly to also support the electrification of the economy and of the building stock. So Germany made the decision to remove a significant chunk of levies which had been placed on electricity. That's the EEG policy, for those of you familiar with electricity policy in Germany. And they shifted that from bills into the public budget. So they shifted income, which had currently revenue, which was being taken from energy bills, and shifted that into the public budget. So it spread over a lot longer time. And in doing so, the price ratio was reduced from a very high 4 down to 3.2. And that might not be below our 2.5 or below our 3, but clearly a significant shift has taken place in Germany. And when you look at the bars on the right-hand side, you can see the difference that achieved. And that hatched blue area on top of the electricity graph for 2024 shows what the prices would have been had that hatched area not been removed, and how that ratio has been brought down. So a relatively simple approach in Germany, administratively quite simple at least, of moving levies which have been being raised from bills and putting them into general taxation. In the US and in China, there are multiple examples of what states and regulators can do, but these are two examples of where smart pricing or time of use pricing has been used to encourage heating electrification. So in Massachusetts, all households with heat pumps have access to electricity rates which are lower in winter. So part of this network cost burden has been shifted out to the summer, basically. And so heat pumps end up being about 4% cheaper to run than gas. Of course, this has knock-ons for other users, but it's one way that you can see smart tariffs being used to encourage adoption by giving people cheaper rates in winter when the heating is on. A similar but slightly different example is in Tianjin City in China, where during the heating season, typically households and building owners see tiered pricing, where prices are more expensive at peak hours, and that might be between, I think, 8 a.m. and 8 p.m. These peak prices have been removed for people with heat pumps or for homeowners with electric heating. And what that means is that basically, if you don't have electric heating, your electricity rates are higher, whereas if you do, your electricity rates are lower across the entire day rather than just at certain periods. In addition to that, there are capital grants and further electricity discounts available in different parts of China. Notably, researching these tariffs can actually be quite difficult, as I discovered as part of this project. Denmark was a leader, I think, in terms of looking to reduce electricity costs for electricity being used in heat pumps. So Denmark exempted electricity that was going into heat pumps in 2021, way ahead of other countries, really. They simply said that if you've got a heat pump, you report it to your supplier and you have a certificate which you can do that with, which comes with the heat pump, and your electricity use over a certain amount will all be totally tax-free. Taxes on electricity in Denmark have been quite high, and so that made, and gas, I should say, but that made a significant chunk in electricity bills, leading to significantly lower heat pump running costs in Denmark. And so this has always been an example that we've been able to point to as very good practice for a few years. It's worth noting that in light of concerns over electricity prices in Denmark, all residential electricity use has actually been reduced to minimum tax levels for the current year and for next year too. So while Denmark made very early progress, specifically on heat pumps, this tax exemption has been extended to cover all electricity use in Denmark. So Sweden took a different approach. Sweden has had a carbon tax on fuels since the early 1990s, and this has been significantly increased over the years to the point now where I think it's around 120 euros per ton of carbon, probably one of the highest carbon taxes in the world. But this has been part of a suite of functions which have led to heat pumps growing as the core heating solution in Sweden. And the graph here compares a heat pump, total ownership and running costs in blue. So that's the cost of the heat pump annualized over a year, and the running costs compared to an oil heating system in red, which includes the running costs and an annualized cost for the oil heating system. And you can just see what a difference the carbon tax makes in terms of costs. Basically, it's half the cost of an oil heating system to have a heat pump over its lifetime. So that is the impact that you can have if you use carbon taxes effectively, amongst other measures. And then in the Netherlands, the Dutch have taken a full sort of rebalancing approach, whereby electricity has become cheaper and gas has become more expensive. And so rather than simply bringing one down to the other, both have been leveled to try and meet each other. And that's resulted in this price ratio in the Netherlands being around 1.5, which is certainly very low by European standards. That has been achieved by increasing taxes on gas. There has been a huge national concern over gas in the Netherlands because it's primarily imported from people that the Dutch don't want to be importing from. There have been earthquakes too associated with gas extraction. And so there has been a national move away from gas. At the same time that the gas taxes have been increased, electricity taxes were decreased too, to really sort of to strengthen that differential in terms of prices. And actually, more recently, this has been made slightly more equitable as there are rebates given to every household now, to make sure that the impact isn't too severe for building owners. But a very, very significant price intervention in the Netherlands, which really makes electrification absolutely the most cost-effective option for households. Just a few words. So that's all of the case studies that I wanted to talk about. And there's more details of those in the report. Just a few words on the broader impacts of this and around equity and making sure this is done fairly. We always think that however taxes and levies are applied and how they're changed, they should of course be efficient, but they should also be very considered. You can have significant social impacts by altering energy bills, and that obviously needs to be taken into account by policymakers. Um, these price rebalancing measures also need to be considered in the context of a broader set of measures supporting clean heating. That could be associated with what grants are available, for example, for heat pumps or for solar panels or batteries or efficiency, or wider heat planning, for example. There are also various other policy measures that governments can do to manage these social costs, actually. So it could be that you might manage prices in a way that the Netherlands have done and do a full rebalancing, but then provide support through other means, maybe through social security or through tax rebates, as they have done. And finally, uh, it's very possible to bring down running costs of heat pump systems with a broader set of technologies as well now. And so where we see the best running cost potential is where heat pumps are combined with solar panels and with batteries and potentially smart tariffs, smart use. And so a combination of levy and tax reform, as well as deployment of other measures, can be very, very impactful in terms of people's bills. We have done as an organisation at RAT plenty of work on making electricity cheaper, and I've provided a link there to our priority actions for making electricity cheaper. I won't go too much into the details of those, but just back onto how governments can make electricity cheaper. There are really three main things. Some of them I've covered already. They can rebalance prices as the Dutch have done, which can have a really strong signal for electrification and doesn't really cost the government anything, depending on how it's done. Government can exempt electricity from taxes and levies, just as the Danes have done in Denmark. And then also costs can be absorbed into public budgets. And it's worth saying that this is what Germany has done by moving its EEG funding from bills into state funding. And as the UK is doing imminently to remove the renewables obligation, the historic legacy support policy for renewable generation in the UK and is moving that from bills into the public budget. And we're actually seeing significant reductions incoming in the 1st of April. So I'm not going to say much about this. There are a number of priority levers that governments can do to bring down electricity prices, and we can maybe have more discussion around those, but do feel free to look at the paper. It's around efficient use of grids, ensuring that systems are efficient and so on, and that network costs and taxes are fair. But I'm just going to wrap up with a few quick conclusions, and I can see Sam's turned his camera back on, so he wants rid of me, I think. Um, we basically conclude that electricity to fossil fuel heating cost ratio should be no more than 2.5 by 2030 for governments that are serious about decarbonising heating. And that's a sensible and pragmatic goal that's deliverable and reasonable. Electricity markets should be designed to be cheap and efficient. Fossil fuels shouldn't be underpriced. There is a role for fossil fuel pricing, subject to social considerations. Power systems should be low cost. We know how to make a low cost power system, and that should be really at the focus of policymakers, making electricity cheap. Flexibility of electricity should be rewarded, and that involves smart tariffs and smart meters. And support should also be offered for other building level technologies like batteries and solar, which can bring prices down. So, Sam, that's it. Thank you very much.
Thank you, Richard, for a really great presentation. Super clear. I mean, I don't know about anyone else in the room, but very, very clear presentation. So thanks so much. However, you may have some questions, or you may just want to ask Richard a question. It could be sort of related to heat pumps or broader policy more generally, because Richard is certainly a heat pump policy expert. However, I do notice that Claire has popped a question already in the Q&A, and now there's another one there. So for all of our participants, please do pop your questions in there and do upvote others' questions, even if you don't have one to ask yourself. Now, our regular attendees will know that at this point you can switch off for a little bit because I talk about the user's TCP for a couple of minutes. But today I have our special guest, Caroline Hagland Stignor, who's going to tell us about a different TCP. So while the user's TCP, we're all about the intersection of the social sciences with energy technologies. HBT TCP is all about a particular type of technologies, heat pumps. So Caroline, I'm going to pass the floor to you, and you can tell us a little bit about the HBT TCP and also perhaps give a couple of reflections on Richard's presentation.
Thank you very much, Sam. I will go and share my screen. I think you need to stop sharing. And now, do I need to swap or is it okay?
If you just go into presentation mode, I think you just tried and it didn't quite work.
Yeah, does it work now?
Perfect.
Yeah, yes, thank you very much. I am Caroline Hagland Stignor, and I'm working for the Heat Pump Center, which it's hosted by RISE in Sweden. And it's the Program Office and Communication Center for the Technology Collaboration Program on Heat Pumping Technologies. And I will just give a brief information about this, since you have signed up for this webinar. I think you might be a bit interested in heat pumps. This TCP has been going on for a really long time, started already in 1978. And it's like it uses TCP. It's another international framework for cooperation network for different actors working within the field of heat pumping technologies to exchange knowledge and experience, and also to contribute to technology improvements by performing a lot of research and demonstration development projects. At present, we have 20 member countries around the world in America, Europe, and Asia. You can see them all listed here. And when we talk about heat pumping technologies, we include those that works for heating and cooling, for air conditioning and dehumidification, and also for Federation, and we cover applications in residential and commercial buildings, industries, thermal grids in cities and communities, and also in other type of applications like the transport sector, for example. And here you can see, I will not go through this in detail. These are the different priority areas for our research and development projects. And we, as you see, the titles here above the projects listed in black are recently finalized, the blue are ongoing, and the red one are in discussion. And if you would like to learn more about our different projects, I recommend you to visit our website. And you can see the address here, and I've also put the link to it in the chat. So of course, the largest thing we do with the TCP is, of course, this international collaboration projects, but we do also work a lot with communication and dialogues. So we publish the reports from the projects, and we publish a magazine and a digital newsletter. We run a website with a lot of information. It's recently been updated and it includes introductory information about the technology as well as deep dive. And of course, we are active on LinkedIn and WeChat. Every third year, we organize an international conference, and the next one will actually take place in Vienna in May, and I will come back to that. Then we do a lot of other things like organizing different meetings, workshops, webinars, and we provide support and review to IA publications and so on. And here we can see the conference that will take place in a couple of months. Early bird registration is open until Saturday, and it will be possible to register later as well, but a little bit more expensive then. And this is a really program here with workshops, technical visits, a lot of different sessions, exhibition, and also policy forums. So it's, if you're interested in technology and policies related to technology, it's a good place to be. And here are some contact information. I'll not go through that, but I will finally just some reflections and experiences from Sweden related to research presentations. And I'm from Sweden, and you can see here on this chart, here we have the ratio of the electricity price to gas and sales of heat pumps per household. And you can see that Sweden, we are quite high here, and we also have a really low ratio here. And this was one of the factors we have managed with this rollout of heat pumps and phasing out fossil fuels for heating. But it was also combined with a lot of other policy measures. But the rationale was according good electricity infrastructure, relatively cheap electricity. And but there was also competition with the district heating and green district heating, and this made it necessary to manufacture really cost-efficient technology as well. And policies also work with continuous research and innovation programs. And of course, in Europe, we have the eco design and energy labeling regulation to label the technology. But we worked with to have skilled and efficient installers at competitive prices, and worked also a lot with different measures to create consumer trust and to create acceptance for the technology. So yes, some reflections here. Thank you very much.
Thank you, Caroline. And yes, it's great to have the Heat Pumping Technologies TCP in the room with us today. Just to say that last summer we had a great joint workshop in Stockholm with the Heat Pumping Technologies TCP, and we heard the Swedish story about heat pump take-up. And I was actually very taken by some of those measures you had on the right-hand side of the slide there that you just showed, which are a bit less well known than the classic story around the carbon tax. Particularly around building consumer trust and the publication of test results and things like that, which especially in the early days of heat pumps would have been super important. So thanks very much, Caroline. Now, I'm just going to turn off the video at this point and we'll move into the Q&A.